Hello everyone, this is James Shore with another how-to video. I'm recording this on February 2nd, 2016. In previous chapters, we've been working on a simple tab switching effect, and that is now done. Now, as I said at the very first episode, the purpose of this series was not so much to create this simple effect, because this is really easy to do, but to demonstrate how to do it in a professional and rigorous manner. So what we have now is an automated build that checks all of our code for source code mistakes using lint, runs it on all of these browsers, IE 11, IE 9, Safari, Chrome, Firefox, Android, and iOS. And we used test-driven development to make sure everything had a good test. And we did a lot of work on having clean, clear, easy to understand, and maintainable design. Now in this chapter, we're going to wrap everything up. This is a graduation ceremony of sorts. In this episode, we're going to look at one last advanced topic, and then in the next episode, we'll look at where do you go next? Where do you take this from here? Our topic for this episode is test doubles. And I want to bring this up not because test doubles are something that I think you should be using a lot. You may have also heard them called mock objects. Mock objects are actually often overused. They're an advanced topic, and not only are they advanced, but when you use them, you can create some very complicated code that when you get it all working and figured out, just feels really nifty and neat and complex and neat gears meshing all around. I have to warn you, avoid the temptation to enjoy that feeling. The best people, the expert programmers, they know how to make code that is great because it's simple. Beginners and even intermediate programmers make code and they think it's great because it's complicated or complex, but the opposite is actually true. The best code is deceptively simple. And mock objects and test doubles in general fail that criteria. Now, I do need to make a correction. Mock objects were originally created by Steve Freeman and Nat Price as a design technique, and that design technique is described in this book right here, Growing Object-Oriented Software Guided by Tests. That style of using mock objects as a way of understanding the relationships between the classes in your design, that has a lot of value. What I am complaining about and what I want you to avoid is the way people commonly use mock objects, which is as a way of disconnecting their code from other parts of their system and making very complex tests. In this episode, I want to show you what that looks like when you actually do it, not so you can learn how to do it yourself, but so you can understand how other people do it, so you can, when you see it, because a lot of people do this, and so you can see what to avoid. Before we get into this, let me explain what people are trying to do. There is a school of thought out there, a misguided school of thought, in my opinion, that says that when you're testing code, that all your code should be unit tests. And it shouldn't. And for more details about that, see this Lessons Learned video right here. There's actually multiple kinds of tests you can write with test-driven development: unit tests, focused integration tests, and end-to-end tests. And I can't go into those details right now, but again, see this Lessons Learned video. But some people think that your tests should only be unit tests, and they also use a very peculiar definition of unit test. They say that a unit test should only run code in the file under test. And you can see that our test fails that. When we run our first test here, use a class to hide all content elements, and we pass in our DOM elements, those DOM elements end up getting methods called on them like remove and add event listener. When we call those methods, we're running code that's in the DOM, and by doing that, we're leaving the bounds of this file. That is perfectly fine. Now, it is true that a good unit test should not leave the bounds of your process. It shouldn't talk to the file system or go over the network or something like that. But talking to the DOM, that's still within our same process. That's okay. But there are people who say you can't do that. You really need to stay only in this file. And in order to do that, what they have to do is pass in different objects. Rather than passing in a real DOM element here, they pass in what's called a test double that has a fake version of add event listener on it, a fake version of class list.remove, a fake version of class list.add. Passing in those different kinds of objects, those different dependencies, is called dependency injection. Dependency injection is a fancy word for saying passing in your objects. That's really all it is. So by passing in our tabs here and our content elements here, we're injecting our tabs and our content as a dependency. Well, when you use codependency injection, which is a great technique and I recommend, but it's overcomplicated by a lot of people, and you certainly don't need a fancy dependency injection framework to do it. You just need a variable that you pass in. At any rate, if you do dependency injection, that gives you the option of passing in a real thing in your production code or a fake thing in your test code. And if you pass in a fake thing, then you can control what happens when methods like add event listener are called. Instead of running on the DOM, they run in your fake object. Those fake objects are called test doubles, and there's actually multiple categorizations of test doubles. Most people just call them mock objects, but there's actually different kinds. There's fakes, which are simple implementations of a real thing, like if we were to create a version of the DOM element that doesn't actually work on the DOM, but does just barely enough to make our test work, that would be a fake. There's also stubs that don't do anything at all, but return hard-coded values, sort of a subset of a fake. There's spies, which are fake objects that keep track of how they're called. They're sort of like stubs, except that they keep track of everything that's called on them so that you can make assertions on it. And then there's mocks that are sort of like spies, except that they also have the ability to automatically check that they were called correctly. So fakes, stubs, spies, and mocks, different ways of passing in not real objects for the purposes of testing. Let me show you what this would look like. So what we're going to do is we're going to create a test that works in this, again, misguided way of preventing any code outside of our tabs file from running. So what we need to do is create fake tab elements and content elements that have our own implementations of the add and remove functions on them. To do that, I'm going to create a new file called tabs mocks test. And I'm going to comment out all the tests in here except for the first one, mostly because we don't have time to do all of these. I'm just going to do one and leave the rest as an exercise for the reader. That's you. We're also going to need a mocking library. The most popular for JavaScript is called Sinon, or maybe Sinon. I'm not sure exactly. I'm going to go ahead and download that and put that in our vendor directory, and I'll also update our karmaconf.js to reference it. Okay, I've put Sinon in our vendor directory. I've added it to our karmaconf, and I've restarted all of our test browsers. And everything is now working. I've also checked in. So if we go into our mocks test here, what we want to do is, again, the way this works is we want to run our tabs without running any real DOM elements. So what we want to do is eliminate all calls to the DOM in our test. And the way we do that is by creating a fake element instead. So I'm going to make a function here, create fake element. And I want to set this up so that our default tab can use the fake element rather than creating a real DOM element with a tab. Because remember, if we go down to create tab, here this is creating a real DOM element. It's calling document.createElement, appending that to the actual HTML document, setting the HTML on it, and returning it. We want to avoid that, so I'm going to create a fake element. Now, if you were doing this test-driven, you would sort of figure this out as we go. But for us, because we already have our existing production code, what I'm going to do is run this test, and we're going to see it fail, and I will build out the fake as we go. So I'll start out just returning nothing. That's our fake right there. I'll run that, and we should see it fail with some method not being implemented. Yeah, it's complaining tab element.addEventListener is not a function, which is true. We never created add event listener on our fake. And if we look at this, it's happening in line 16 of our tabs function, or of our tabs file. No, that's handle clicks. Then it's happening here, line 21. Line 22, here it is, add event listener. So I should be able to come into our fake element here and just create an add event listener function. That doesn't do anything for now. Run that test, and now it's complaining can't read property remove on line 33. That's complaining about element.classlist.remove. So let's make a class list object, and on it we'll add a remove function. So you can see I'm making an object here that just has all the same methods that a real DOM element has that we care about. We're not putting in every single DOM method, just the ones that we care about, and continuing on until we find them all. In more complicated programs, this can be hard to do, but if you do it test-driven, it gets built up as you go. It's not that bad. Also, Sinone can automatically stub out these functions for you in certain cases. Not this one, though. It's complaining about add now, so let's go ahead and add that. And there we go. Everything is working. All right, let's go ahead and take out these assertions. We're going to do the assertions differently with our mock objects. Now we should be able to replace the tab content with a fake element as well. Let's try that. All right, that worked. So let's go ahead and replace the remainder of these. We've got a fake element here and a fake element here and here, and there we go. So that's all working. Now that we're using fake elements in our test, we don't need any of our DOM-based code. So we aren't creating a tab, so we can get rid of that. We're not creating tab content, so we can get rid of that. We're not calling add element. We're not going to be calling remove element either. And also, all these assertions are going away too. Furthermore, up here where we create the container element, we don't need any of that because we're not going to put anything into the real DOM. You can see how this would be attractive. It seems like we're really making things simpler by eliminating the DOM from the equation. And it is true, we are making things simpler in that way, but at the cost of making other things very complex, as you'll see in just a moment. But let's make sure all that's working. So there we go. We've eliminated the DOM from this entirely. We've created fake elements, which means that our tabs file, whenever it works with the DOM, is instead calling methods that we control. Which means that now we're doing a kind of unit test, a sort of bastardized version of unit test that's extremely strict and says we never exit the bounds of this function. Some people think that's a really good thing. I obviously disagree. Or rather, I think it can be a good thing, but I think the cost isn't worth it. So now we've got our fake elements. The question is, how do we make assertions on this? Before we were actually looking at the class property of our DOM element, but we're not doing anything up here. We're not actually setting any class elements or removing them. We could implement something to add and remove elements from our class list, but if we did that, we'd start re-implementing the DOM, and that gets complicated. So instead, we're going to use a mock object. We're going to say that we're expecting add and remove to be called with specific functions. What we can do is say, in this test, what we want to make sure is that all the elements are hidden except for the default. And the way that happens is down here in show tab. We add the hidden content class to each element, and then we remove it from the one that's being shown. We can use mocks to do that. Before we use Sinone's mock function, we have to set up our test to work with Sinone. The way we do that is we call Sinone.test as a wrapper around our test function. Now that is going to fail because Sinone's a global and we haven't told lint that Sinone is in use. I'm going to put that up here and say that we aren't expecting to change the value of Sinone. Now that should continue to work. And it does. Okay, now that we have the Sinone wrapper, what we can do is we can say Sinone mock out the class list of our content1 object, our fake element, and expect that the add method is going to be called once with the exact arguments and whatever our hidden content class is. So we're expecting the add method to be called on our class list with the hidden content as the argument. Now, if I run this, it should pass because that is in fact what we're doing. But let's go ahead and turn off our other tests. So we're only running our one mock object test. There you go. It's only running that one. And now let's have this say, hey, don't show the tab. If we do that, you're going to see that our tests fail. We expected add to be called with hide class once, but it was never called. So that's how assertions work with mock objects. You create a mock object and say we're expecting a certain method to be called. The problem with this is it's not talking about the behavior we're expecting, it's just talking about the implementation, which means that if we refactor this code to make it work differently, maybe it doesn't use class list anymore, maybe it sets the class's property directly or something else, this test will fail. Mock methods are brittle. Especially this style of mocking where you're talking about exactly what's implemented. Something to be avoided. Test doubles tend to be very brittle. But we are going to continue on. This is the way that this style works. Again, I don't recommend it, but we're going to show you how it works. So we're going to expect default content and content 3. They're all going to have add called once with the hidden content. Now it's failing. So let's go ahead and put this back. But one thing I want you to notice here is that our test, it's not at all obvious which line is failing. It's saying expected add hide class once, but which line was it? You can't tell from the stack trace because this gets called automatically at the end. What happens, you set up your mocks, you run your function, and then at the end of the test, it will check the mocks to make sure they were called correctly. But in our case, we've got 3 of them. Which one is it? I've not seen any way it's known to put a message on here. Another reason I don't like this code, it tends to be pretty hard to debug and again, fragile, so it will often break. So in order to make this more obvious, what I'm going to say is expect every content element to be hidden and then the default content element should be revealed. Remember, I feel that comments like this are a code smell. It's a sign that something's wrong, but I don't see another choice. So we're going to have the content element be revealed. So let's expect that remove is called once on the default content class list with the exact arguments of hidden content. And that works. And let's go even one step further. No other content elements should be revealed. So content 1 class list should have remove called never. And same for content 3. And there you go. That is a test double based test, a mock based test. You will see people do this extensively in all their code. They will write tests that look like this. But I think it's a mistake. I feel like this is harder to understand than the simple, straightforward test. I feel like the reason they're doing it is to prevent any code from running other than this one file, which is not great. Again, if you want to use mock objects properly, check out this book right here, Growing Object-Oriented Software Guided by Tests. They talk about how to do it right. This is not so good. There's one other problem with this that I want you to notice, which is that because we're not actually running the DOM, we're not doing anything with the DOM, and because the difference in browsers tends to be in the DOM, we're preventing ourselves from finding cross-browser bugs. We've got all these browsers here, IE11, IE9, Safari, Chrome, Firefox, Android, and iOS, and now we're running code that's not going to fail in any of them. IE9 actually has to be, doesn't have support for class lists and has to have it shimmed out. But if I take out that shim, or let's say that I was doing this test driven and never remembered to do it in the first place, and I run these mock-based tests, the tests don't fail. The real tests will. Let me go ahead and turn those back on. The real test will fail perfectly. You'll see that everything works except for IE9 saying that we can't find the value of the property remove. But the mock-based tests don't fail. What that means is that when we run this code on IE9, even though our tests pass, the code actually is failing. So if you're going to use a test double-based approach, a mock-based approach, you're going to need a lot more integration tests. Those tend to be expensive both to write and to run. They're slow and they're brittle. Another reason not to use this style. So that's test doubles. I don't advise that you use it, but I wanted you to understand how it works. I'm going to put everything back here, make sure it's all the tests are passing. And let's go ahead and unskip this one. There we go. So the way this works, once again, you create fake elements, or you can use your real ones and mock them out if you have them. But in our case, we are trying to get rid of the DOM elements entirely. So we are creating fake elements, then using Senone's mock capability to say how we expect the fake elements to be called. Then we're running our code, and Senone is checking to make sure that these mock elements, these mock expectations are being met. This code is harder to read, it's more brittle, it prevents refactoring from happening. It's not a good way of testing, but you will see it a lot in the wild. When you do, use your own discretion about whether or not you tell people to stop doing it. If you're a junior programmer on a team, it might be best not to say anything at all, or you can tell them to watch my videos, one of the two. Your exercise for this time, if you want, you can go ahead and implement these mocks using Senone. It's worth understanding how to do this because it's so widespread. For those of you doing challenge exercises, I'm going to leave these remaining tests for you to do on your own. I have to warn you, once you start getting into tests that do clicking, your fake gets a lot more complicated, and the ordering that has to happen with your mocks also gets a lot more complicated. Fair warning, you might run into some challenges there. If you want an even bigger challenge, you might actually find this easier to do if you try test driving with the mocks from the beginning. So start with a blank slate, start your tabs library over, and test drive it using the mock-based approach. That is up to you. It's a lot of work to do something that I actually don't think is a great thing to learn how to do, but it's worth knowing. So if you really want to dig into this, that would be worth doing. All right, next time we're going to have our final episode. We're going to talk about where do you go from here. Thanks very much for watching, everybody, and I will catch you next time.